Welcome back, as we next discuss the operating principles of a capacitor run motor, also known as a permanent split capacitor induction motor. Capacitor run motors are ideally suited for frequent stop-start operations and can tolerate the stress of starting a flywheel type load such as a cooling fan or blower. In its most basic form, the motor is virtually identical in construction to the capacitor start motor except for two key differences, namely, the start capacitor is replaced with a smaller run capacitor, and the start winding remains permanently connected to the supply, thus eliminating the need for a centrifugal switch. The run capacitor has a much smaller capacity than the normal start capacitor and is rated for continuous operation since it remains permanently connected to the start circuit, which is always connected to the main supply. This type of motor has less starting torque than the capacitor start motor. This is due to the reduced capacitance of the run capacitor, which is optimized for best performance and efficiency when the motor is running at its rated speed. The final variation of capacitor-type induction motor we shall discuss is the capacitor start, capacitor run motor. As the name suggests, the motor has both a start capacitor and a run capacitor. This produces a high starting torque in addition to a good running torque. Such an application is required by an air compressor unit where the motor often has to start against a load and run efficiently under a load. The motor incorporates the same major components found in the other two types. However, both a start and a run capacitor are employed. The schematic diagram shows the two parallel circuits, namely the start circuit and the run circuit. At switch on, both capacitors are connected in series with the start winding. But when the motor reaches 80% of its rated speed, the centrifugal switch opens. The start capacitor is disconnected, but the run capacitor and the start winding remain connected to the main supply, providing a high running torque. This concludes our overview of capacitor-type induction motors. After the break, we will continue with electrical test procedures.